So hello, I'm Blake Kellner.
Hi, my name is Tony Sanchez, and I'm a senior here at Radford University.
I'm Carson Perkins, and I'm a senior here at Radford University as well. And our project is on vaccination verification database. And so the problem that we were presented was the implementation of verifying vaccination cards for everyone over the age of 4 years old. And so we needed to find an implementation that would allow us to allow verifiers to verify these vaccination cards to allow access into public spaces. So restaurants and bars and grocery stores and everything else. And so we decided to go with DynamoDB, Amazon's DynamoDB. And the reason that we went with DynamoDB is because we thought that it was a more flexible solution for the entities that we had, and it would scale very easily. Because in terms of the problem that we're presented is that if this was actually implemented, that it would scale to an entire nation, which would result in lots of requests. So we felt that DynamoDB was a good solution for it, and that relational databases fell short with that requirement because for the join would have the speed of that to be lower than what we needed.
Again, we went with DynamoDB. It's a key-value NoSQL database that stores entities based on partition keys. In this example that we have here, you can see that put item, its partition key is its customer ID, which is then hashed, and based off of that hashed partition ID, the data is then stored within one of the partitions, in this case being partition 1. And another thing that is specific to DynamoDB or databases of this nature is that, as opposed to relational databases, it is necessary to it's important, it's smart to build the database around the queries that will be asked mainly. So with that in mind, we based our database structure and our database structure off of these 5 queries. How to retrieve a person's information by their identification number, retrieving a person's information by their phone number, accessing all requests by a person's identification number, accessing a certain verifier by their identification number, and viewing all vaccination card misuses day by day.
And so from those queries, we determined first our index schema and the entities that we would need to store in our database. So to the left is our index schema, which the first column outlines the entities that are going to be stored in our database. So we have a person, entity, a verifier, a request that's made by a person to a verifier, and then finally a PVCMA, which is the card misuse alert. If there's any problems in the request, there will be an alert generated from that. And so along with that, we have our partition keys and sort keys. And one case of a global secondary index for the person entity so that we can reach their data by phone num as well as their identification number. And for a verifier, we just reached out to them by verifier ID. The request is indicated by the person's ID along with the timestamp of the request. And then the alerts are partitioned by date and then the person's identification from there. And so to the right is our entity relationship diagram to see how these entities are interacting with each other in the database. And so from our index schema and our ERD, we went into the table design for DynamoDB. And in this case, we use a single table design. So all of our entities are stored in one table, which is not normal to a relational database where there's multiple tables for a given entity. Where in this case, we have our persons are identified by CID along with the metadata is to get that person's information. If you do a query request CID and then timestamp, that is all the requests of that given person. Along with that, we have VID, which just gets the information from the verifier, such as location and phone number. And then finally, we have our misuse alerts. So here are just a few screenshots of our query execution to kind of see what the data looks like in our DynamoDB database. To the very left is just our request for a given person. So we have 3 or 4 requests there. The middle is extracting a person's information. We can see their name, their address, any dependents they have, along with their vaccination information. This determines whether they are valid or not, whether their vaccinations are valid. And then on the far right, we have our misuse alerts. We can query for all the alerts for a given day, and that's the output of what that query looks like. So moving on to the lessons learned from this project, it was definitely an experience that we gained a lot of knowledge from. First off, we had queries must be thought of first instead of in a relational database where you're not as much worried about the access patterns to your data.
As though we gain much experience working with a non-relational database.
And also learned that unlike relational models or unlike relational databases, the query results are not formatted whenever they come back. So the data might be in a different order than what you inserted them as, which is much different than a relational database.